How did the first bridges handle weight distribution? Imagine crossing a river on a structure that seems to defy gravity. How did those early builders make sure the bridge didn't fall apart under heavy weight? Well, the secret lies in how they managed the forces acting on the bridge. The earliest bridges used the arch shape to handle weight. When you step onto an arch bridge, the weight pushes down on the curve, and that force is directed outward toward the supports at each end. These supports are called abutments. This way, the load is transferred into compression along the arch, which is perfect for materials like stone that resist squeezing well. Ancient civilizations, especially the Romans, took this idea and made it better. They built stone arch bridges by carefully shaping wedge-shaped stones called voussoirs. The keystone, placed at the top center, locks all the stones together and spreads the forces evenly. This design meant the bridge could support a lot of weight and span wider gaps without collapsing. The Romans also used concrete to make their bridges stronger and last longer. These innovations allowed 4 longer-lasting bridges that could carry carts, soldiers, and even entire armies across rivers and valleys. Before stone arches, people used simpler methods like wooden beams or floating pontoon bridges. Wooden bridges used horizontal beams supported by piles driven into the ground or riverbed. These were less durable and could only span short distances. Pontoon bridges floated on water and transferred weight directly to the water surface. They were quick to set up but not meant for permanent use or heavy loads. The main idea behind these early bridges was to direct forces to stable supports and avoid tension, which materials like stone and wood can't handle well. This approach was a major step forward in building reliable crossings. It made it possible to develop cities, expand trade routes, and move armies efficiently. The arch design still influences bridge building today, showing how a simple shape can handle complex forces. These early innovations in weight distribution laid the foundation for modern infrastructure and changed how humans connect across obstacles.